Okay, hi guys. We're just going to go through a few of the angle things again. So I know that quite a few of you, when I was looking at your work, your angles around a point were good, your angles on a straight line were good, your vertically opposite angles were good as well. However, I didn't see enough practice on the triangles, and I think I only saw one or two people on the quadrilaterals. So I'm just going to give you another lesson just to catch up on the triangles and quadrilaterals. And then for those people that did actually do it, we've just got an extra task at the end. So when I do finish this one, can you just make sure those people that haven't practiced the triangles and quadrilaterals get on and do it? And then for everyone else, we'll just do a little bit of extra work. So the extension work will be at the end of the video. Okay. So just getting on with this. You just need to apply your rules. I've put a big version over there so you can see it nice and clearly rather than my wonderful, tiny, messy handwriting. You can see a nice version over there. So I'll pop this question on when I'm working on this one. I'll pop this one on when I'm working on that one. Okay, so if you want to pause right now and make sure you copy that diagram down and see what of those you can actually finish, yay. And then you can unpause and then we'll work through it all anyway. And then we can do the same for down here. It's entirely up to you. I would suggest doing it just so you definitely know that you're like this with your angle rules. So if you want to take actually, why am I telling you to take a minute? You can just pause, copy it out, unpause. You can hear my wonderfully, I don't know, whatever my voice sounds like, you can hear that when you unpause. So I'll just carry on because I'm assuming you paused and this is your unpause stage. Looking at this first one, what kind of things do I know about this? So first of all, I would just say, what angles are they asking me for? So I know they're asking me for this one. So I'm going to colour in that one. I know they're asking me for this one. Oh, what happened there? Okay. I know they're asking me for this one. I know they're asking me for this one and this one. Just looking at this, first of all, it does look like quite a few angles. But can we just work out most of them just by looking at it? Obviously, I've drawn in pencil. Please draw your diagrams in pencil. There's quite a few of them. So if I look at this one here, I can see that this is angles on a straight line. And I know that angles on a straight line add up to 180 degrees. So if they add up to 180 degrees, then 180 take away the 106 will give me 74 degrees for this one. Okay. And then I can do the same for over here. This is a straight line, so that must mean I'm going through the same thing. Or you might have thought this is vertically opposite to this. You could have done that, and then vertically opposite angles are also equal. So you could have thought about that as well. Okay, for this one up here, you have exactly the same thing. You have a straight line, so 180 take away 117 would leave you with 63 degrees, and then you have vertically opposite angles. So this would be 63 degrees. Obviously, if you did straight line with that one again, that is perfectly fine. You could have done that as well. This one, nice and easy. If you have angles on a straight line and one is a right angle, what is the other one? Also a right angle, it's 90 degrees. And this one down here is just angles on a straight line. So I've got angles on a straight line, add to 180 degrees. So 180 take away 133 would be 47 degrees. Okay, so if you got all of those, that is great. Let's move on to the second one. Okay, so that's the second one. I'm going to highlight in a slightly different colour potentially. Yeah. So for this one, they are asking for, obviously when I'm going through these, I didn't bother figuring out any of the other angles. I just wanted the angles that they asked me for. So for this one, obviously you got that angle that I've already highlighted, this one here, this one, and this one. Okay, so we need to work out those angles. So for this one, I would say angles on a straight line add to 180 degrees. So 180 take away 139 would leave me with 41 degrees. This one is angles around a point. So angles around a point add to 360 degrees. I'm sure you just said. So 360 take away 296 would be 64 degrees. Okay, this one I've got vertically opposite angles here. So if this is 142 degrees, this is also 142 degrees. And then these ones are angles on a straight line. So this is 142, this must be 180, take away 142, which would be 38 degrees. And last but not least, I've got that one right there, and I know angles around a point add to 360 degrees. So I need to do 360, take away 162, take away 77, which leaves you with 121 degrees. Okay, so that was just good practice for the first 3 rules, which I know quite a few of you did. Okay, and now we're just going to double check on the triangle and the quadrilaterals. Just hold on a mo while I... Okay, so the next lot with your triangles and your quadrilaterals. So I don't know whether you want to copy out, those diagrams are obviously much nicer than mine, so just make sure you pause, copy them out, and then we'll move on. You need to leave space for working, so you probably want to copy one, then pause, do the working on it, then once we go through it, then pause for the second one. Does that make sense? So just do it as we're going along. Otherwise, you might not have enough space when stuff is squished together as notes. Half the time, it's like, I cannot read my notes if I squish them together. So I don't know if you're able to or not. If you are able to read your squished up notes, you are a very talented person indeed. But anyway, we are going to use our properties of 2D shapes in order to help us solve these. So you should remember from the properties that we were doing where you had to draw out the shapes and you spoke about how they're equal sides and everything else. And this is where we're kind of going to use it because it's going to help us find out the angles. So here I have a special type of triangle. So you may have noticed what type of triangle it is. It's got 3 equal sides, so that is an equilateral triangle. So an equilateral does not only has 3 equal sides, it also has 3 equal angles. I know that angles in a triangle add up to 180 degrees. So that means I need to divide it by 3 in order to find out what one of these angles are. So this is actually 60 degrees. Okay, the next one. It is an isosceles triangle, so I know that both the base angles are exactly the same. I know when I was talking about it, because base is usually the base, you can just swing it around so it looks like the base angle, which is perfectly fine. Me, I usually just say that 2 angles are the same, but I know that the way I usually have seen it on the internet is a lot of people say base angles, and I think that can kind of be misleading, especially if you're like me and you think the base is always at the bottom. So isosceles, I've got 2 equal angles, so I know this is E and I know this is E. I know angles in a triangle add up to 180, so the first step I need to do is 180 take away 50, which leaves me with 130 degrees. So I've got 2 angles that add up to 130 degrees, so I need to do 130 divided by 2 leaves me with 65, so this must be 65 degrees. Okay. This one is a lovely one, so anyone who knows me knows that I love a challenge. So I've actually got 2 sets of isosceles triangles. You just need to ensure that you see them as 2 different sets. So anyone with their wonderful highlighter pens out, you've got 2 equal sets. So you've got the triangle just there. And you've got a different triangle just there. Okay, both of them are isosceles in their own way. So you will notice there is the one line in the triangle on the left, and you've got 2 lines with the triangle on the right. So this one, these 2 angles are exactly the same. I don't actually know what they are right now, so I'm going to have to work them out. So angles in a triangle add up to 180 degrees. I've got 180, take away 40 is 140 degrees, because that's 40 So these two must be 140 altogether, so it must be 70 by themselves. Okay, I cannot find out this angle here, so don't start looking at that angle until I get to something else. But can I find out that angle up there? They give me 192 and they give me 70. I know that angles around a point add to 360. So if I take away 70 and I also take away the 192, I am left with 98 degrees just there. Okay. Again, it's an isosceles. I've got two lines here, I've got two lines here. That means these two lines are exactly the same. I've got another isosceles. So I'm going to do 180, take away 98, leaves me with 82. Okay, and I've got two angles that add up to 82. So 82 divided by 2 is 41 degrees. So this one must be 41 degrees in the same way that this is 41 degrees. Okay, you will not be penalized for adding on extra angles. Me, I always do that just to show it's my working, so that examiners can see that I'm saying, oh, these two must be the same because it's an isosceles. Okay, so that's my triangles. And then we have quadrilaterals. So angles in a quadrilateral add up to 360, I'm pretending to hear everyone say. Okay, so I've got this one, right angle, it's 90 degrees. I always write it in because if I don't write it in, I might forget about it, because otherwise I might just go, oh, 360, and I'll take away these two, and in my haste, I'll completely forget that this one exists. So I always write it in for that sake. Okay, so now I've got them. I would just do 360, take away the 90, take away the 80, take away that 85. I am left with 105. I am going to make sure I write down everything that I pop into my calculator. I'm going to write down. That way, if anyone ever says, what did you do? And I'll say, well, I did 360, take away 90, take away 80, take away 85. Okay, nice and easy. So this one, you will notice there is one set of parallel sides, there are two same sides, so that must be an isosceles trapezium. Okay, it's isosceles, so that must mean that this is also 70 degrees. I know these two angles are exactly the same as well. So I know angles in a quadrilateral add to 360. So I'm going to do 360, take away 70, take away 70. That leaves me with 280 degrees. I've got two angles that add up to 280 degrees and they are both equal. So 280 divided by 2 is 140 degrees. Okay. This one, it is a, well, it could be a rhombus or a parallelogram. I'm just going to call it a parallelogram because that covers all my bases. Because those two lines are parallel, these two lines are parallel. Opposite angles in a parallelogram are, should remember, if not, make sure your notes reflect this. Opposite angles in a parallelogram are equal, so M would equal 125 degrees. Obviously, angles in a quadrilateral add up to 360. So I'm going to do 360, take away these two angles. So take away 125, take away 125, which is 250, which leaves me with 110. So I have two angles left, which is 110. So 110 divided by 2 is 55 degrees. Okay, so as I said, from this point, I'm going to be doing some extension work, but for everyone else that didn't complete the triangle and quadrilateral work, I am expecting you now to finish off that quadrilateral work, just to ensure that we are all caught up, because I don't want to keep going ahead if I haven't seen evidence of you understanding what this is. Okay? Okay, so for those people doing the extension work, I would like you, in your books, you do need to be measuring the angles, so don't make the shapes too small, but in your books, I would like you to draw out these shapes. So it doesn't need to be exact, I just need a triangle, it could be any triangle under the sun. I need a quadrilateral, it can be any quadrilateral under the sun. I need a pentagon and I need a hexagon. Because I've just drawn it on a piece of paper, I haven't cared about the angles. Obviously some of you, because I've told you you're measuring the angles, might want to make some easier shapes so the angles are much easier to measure, but entirely up to you there. I want you to pause the video, draw out these 4 shapes, and then also measure the angles within and add them up, because I would like to know what they add up to. Okay, so I'm assuming you have now unpaused. So when I'm looking at each of these angles, so the angles in the triangle should have added up to 180 degrees. The angles in the quadrilateral should have added up to 360 degrees. The angles in the pentagon should have added up to 540 degrees. The angles in the hexagon should have added up to 720, not 72 degrees, as I nearly wrote there. Okay, so those are what you should have added it up to. If you are about 5 degrees out, that means I'm not sure how you're measuring. So you need to ensure that your measuring skills are much better. Also, in terms of your pencil, I've left this pencil a little bit blunt because if I make it too fine, it's very hard to see. But you need to make sure that you get a nice sharp pencil when you're drawing, because thick lines can throw your degrees off by at least like 1 or 2 degrees per shape. So make sure you have a nice sharp pencil when you are drawing these shapes, okay? Anyway, so these are the totals that you should have gotten. So did you notice anything about them? If you did, you may have noticed, what do I have to do? It's a gradual change. So this is like a sequence where I have a constant change. And I'm adding 180 degrees each time. And which of these shapes has 180 degrees? Okay, so angles in a triangle would add up to 180 degrees. So if you're thinking triangles, or you've even looked at the exterior, interior angles within a polygon, you would kind of notice that it talks about triangles. So you basically go from a corner. What can I do to any quadrilateral? It's not the most amount of triangles, it's the least amount of triangles I can make. So whenever I'm going from any polygon, you choose one vertex or one point, and you just go from that one point to every other point as far as you can go. Okay, so within the triangle I've got 1, within the quadrilateral I've got 2, within the pentagon I've got 3, within the hexagon I've got 4. Some of you may have realised what the pattern is, some of you may have not. So you've got 180 degrees. This is one triangle, so it's 1 times 180 degrees. This is 2 triangles, so it is 2 times 180 degrees. This is 3 triangles, so it is 3 times 180 degrees. This one is 4 triangles, so 4 times 180 degrees. Okay, and you will notice that is what each of these equal. Okay, so a 3-sided shape would have 1 triangle. 4-sided shape would have 2 triangles. So hopefully you've got this in your book, because I am about to move it. I know. So if I was talking about a shape, I would have, so I'm going to put shape, I'm going to put number of sides, I'm going to put number of triangles. If you've looked at the sheet will already have this. So if you do copy notes directly into your book, then you would need to copy out the table it has in the worksheet online. If you're able to print it off, you can just print off those actual worksheets, and that will give you enough notes to write all of this down. I'm just going through this as a reference. Okay, sum of interior angles. Okay, and just as a side note, because you may not know this, interior angles would be the angles that are interior to the shape. This is interior. That's an interior angle. And the sum is if I add all of them up. Okay? Just in case anyone's questioning what sum of interior angles mean. Sum means you add up, and then interior just means the angles that are interior. Okay? So if I do look at this, so my shape was a triangle, there were 3 sides, I had 1 triangle, so the sum was 1 times 180, which is 180, right? Quadrilateral had 4 sides, 2 triangles, 2 times 180 equals 360. Next one was a pentagon, 5 sides. Number of triangles, 3. Okay, so we've got 3 times 180. Okay, hexagon, 6 sides, 4 triangles, 4 times 180 is 720. Okay, I want you to keep running it down. So we've got heptagon for 7, we've got octagon for 8, we have nonagon for 9, and we have decagon for 10. Okay, and just as a little bit of extra, what if I said it was an n-sided shape? I want you to pause now and just try and see if you can finish off the rest of this table. And I'm going to pause as well, so just make sure you pause. Okay, so looking at this table, you will obviously you should have noticed. I'm so sorry about that. You should have noticed that the number of triangles. What does it do? What do you do to this each time? You would take away 2, take away 2, take away 2. Okay, so if I had the nth shape, as in I'm not sure what number of sides, the way to find out the number of triangles is to take away 2 from n. Okay. And then when you say the sum of interior angles, that would be n, take away 2, and then I just need to times that by 180. Okay? So if I had a shape and they asked me what the sum of the interior angles is, I would just be able to say, well, if it's a hexagon, I need to do 6, take away 2, which is 4, 4 times 180, and that would give me the sum. Okay, and then we'll just go through a couple of questions and then I will let you get on. Okay, so a couple of other questions for you that use this. So what would I do? Up here, I have a hexagon. So in terms of the hexagon, I kind of think, well, it's 6 sides. So that means 4 triangles, right? So if there are 4 triangles, that needs to be 4 times 180 degrees, which is 720. So in order to find out what h is, I would have to subtract the rest from 720 degrees. So you've got 720, take away 70, take away 160, take away 95, take away 105, take away 55, which equals, I'm going to use my trusty calculator for 60, take away 95, take away 105, take away 55, equals 235 degrees. That would be my answer. Okay. This one, beautiful diagram. You've got loads of lines everywhere, and it even tells you that the shapes are regular. So if they are regular, the same as we did for the equilateral triangle, I would say they have the same size length and the same angles. So I would say for these, all of these must be 60 degrees. So I automatically know this is 60 degrees, that's 60 degrees. Okay, don't need to label the rest because I only need to know about P. And then for these, that is a 5-sided shape. So I've got 5 sides, so 5 take away 2, 3 triangles, 3 times 180 degrees is 540. Because it's regular, I've got 5 equal sides, so 540 divided by 5, because there's 5 angles, is 180 degrees, 108 degrees, sorry, I say 180, anyway, 108. So I've got 108, and then, last but not least, I've got angles around a point, So angles around a point, add to 360. So for this one, it will be 360. Take away the 60s that I already know, but also take away this 108. So 360, take away is 132. So I know P is 132. Okay, so that's how you would sometimes use this. So what I would like you guys to do for the extension work is I have put the exterior angles worksheet in there. I would like you to check it out and see if you can fill it in. Essentially, that sheet will cover all the notes that you kind of need. You might want to take down like these couple of examples, which is perfectly fine, but then complete the sheet and obviously submit the work that you can do within the lesson and reflection time. Okay, take care, guys.